Welcome to month 4 of the Data Engineer track. Today's session is all about data quality and testing, arguably the most underinvested area in most data teams, and also the one that determines whether anyone actually trusts the data you produce. We'll cover quality dimensions, validation frameworks, data contracts, and monitoring. By the end, you'll have built a complete quality framework from scratch. Here's the plan for today. 4 hours of combined lecture and hands-on challenge work. The first hour covers the conceptual foundations, quality dimensions, and the tools landscape. The second and third hours are deep challenge time, where you build a real quality framework. The final hour is for demos, best practices, and retrospective. The challenge scenario is an e-commerce company that has been plagued by data quality issues. You'll produce 4 deliverables: a quality assessment report, a break expectations implementation, data contracts, and a monitoring dashboard. These aren't toy exercises. Every one of these deliverables is something you'll build in a real production environment. 5 clear objectives for today. First, data quality dimensions. You'll learn to measure quality across 6 standardized dimensions: accuracy, completeness, consistency, timeliness, uniqueness, and validity. Each one maps to specific metrics you can compute. Second, validation frameworks. You'll implement automated data validation using great expectations, learn how DBT tests fit in, and see how OpenMetadata provides governance layer quality. Third, data contracts. This is the practice of formally defining what data a producer promises to deliver and what a consumer expects to receive. Think of it as API contracts, but for data. Fourth, quality monitoring. You set up dashboards and alerts so quality issues are caught before they reach consumers. And fifth, quality culture. Embedding quality checks into your CI/CD pipeline so quality becomes a habit, not an afterthought. Let's start with the foundation. There are 6 universally recognized dimensions of data quality. Every quality problem you'll ever encounter maps to one or more of these. Accuracy. Does the data correctly represent reality? If a customer's address says New York, but they live in Chicago, that's an accuracy problem. You measure this with error rates per batch. Completeness. Are all required values present? Null fields, missing rows, truncated records. Measure it with null ratios per column. Consistency. Does the data agree with itself across systems? If the orders table says a customer spent $500 last month, but the billing system says $480, you have a consistency issue. Cross-source match percentage is your metric. Timeliness. Is the data fresh enough? If your dashboard shows yesterday's data but your SLA promises hourly updates, timeliness is broken. Track freshness, SLA adherence. Uniqueness. Are there unintended duplicates? One customer appearing 3 times inflates your metrics. Count duplicate rows. And validity. Does the data conform to business rules? An age of -5 or a status of maybe, when only active and inactive are valid. These are validity failures. Track constraint violation rates. In Azure, data factories, built-in derived column transformations, can compute null ratios and constraint checks in line. Azure Purview's data quality features profile completeness and uniqueness automatically. Now let's talk about where your organization sits on the maturity curve. There are 3 stages. Reactive is where most teams start. You find out about quality issues when something breaks downstream. A dashboard shows wrong numbers, a customer complains, a report fails. You fix it, move on, and hope it doesn't happen again. The hallmarks are manual spot checks, incident-driven fixes, and no formal quality metrics. Proactive is where you want to be. You prevent issues with automated checks that run before data reaches consumers. You have expectation suites, CI/CD quality gates, data contracts, and SLA tracking with alerts. Issues are caught in the pipeline, not in production. Predictive is the aspirational state. You use machine learning to detect anomalies before they cause failures. Drift monitoring catches gradual degradation. Self-healing pipelines automatically retry or quarantine bad data. Quality scorecards give each dataset a health rating. The cost of staying reactive is enormous. Gartner estimates poor data quality costs organizations an average of $12.9 million per year. Every 1% improvement in data quality yields roughly a 10% reduction in operational costs. Today's session is about moving you from reactive to proactive. Let's survey the tools you'll work with today. Great Expectations is the centerpiece. It's a Python library for declarative data validation. You write expectations, assertions about what your data should look like, and Great Expectations runs them against your data, generating rich HTML documentation called data docs. It connects natively to Azure Blob Storage and Azure Data Lake Storage, and checkpoints integrate cleanly into CI/CD pipelines. dbt tests work inside the transformation layer. If you're already using dbt for your SQL transformations, adding quality tests is nearly free. Built-in tests cover unique, not null, accepted values, and relationships. The dbt expectations package adds Great Expectation style assertions directly in your dbt YAML files. OpenMetadata provides governance layer quality. It profiles your data at the column level, runs scheduled quality tests, and provides lineage-aware alerting. It integrates with Azure SQL and Azure Synapse. Data contracts aren't a tool, they're a practice. You define formal YAML agreements between data producers and consumers, specifying schema, quality, SLAs, and versioning rules. These contracts are enforced in CI pipelines. For Azure environments, combine Azure Data Factory's built-in quality profiling with Purview for governance and Great Expectations checkpoints in Azure DevOps pipelines. That gives you defense in-depth validation. Let's go deeper on Great Expectations since it's the core tool for today's challenge. The architecture has 4 key components. The data context is your central configuration. It manages data sources, expectation suites, and checkpoints. Think of it as the project root for all your quality definitions. Expectation suites are reusable collections of declarative assertions. Each expectation is a single check. Expect column values to not be null. Expect column values to be between 0 and 100,000, and so on. You group related expectations into a suite. Checkpoints are the orchestration units. They run one or more suites against data batches and trigger actions on pass or fail. Send a notification, fail a pipeline, generate a report. Data docs are auto-generated HTML reports showing validation results. They're clear, shareable, and perfect for non-technical stakeholders. Host them on an Azure Blob static site for team visibility. The code example on the right shows a minimal expectation suite for an orders dataset. Notice how each expectation maps to a quality dimension. The B null check is completeness. The B between check is validity. The B unique check is uniqueness. For your Azure setup, store Great Expectations configuration in Azure repos. Deploy Datadocs to the Azure Blob Web Container for static hosting. Run checkpoints in Azure DevOps pipelines. Data contracts are a relatively new practice that's rapidly becoming essential. The core idea is simple. The team that produces data makes a formal promise about what that data will look like. Look at the YAML example on the left. A contract specifies the owner who is responsible for this data. It defines the schema, exact field names, types, whether they're required, and constraints. And it defines quality SLAs. Freshness must be under 15 minutes, completeness must be at least 99.5%, and volume should be between 1,000 and 50,000 rows per day. 4 key principles. First, producer ownership. The team that creates the data owns the contract and is accountable for meeting its SLAs. Second, consumer-driven. Consumers declare what they need, and producers agree to supply it. Third, schema as code. Contracts live in version control and are validated in CI before anyone can merge. Fourth, breaking versus non-breaking changes. Adding a nullable column is safe, but removing or renaming a column is a breaking change that requires a major version bump. Versioning follows semantic versioning. Major for breaking schema changes, minor for additive changes like a new nullable column, patch for SLA or metadata updates. In practice, store your contracts in the same repository as your pipeline code. Validate them in Azure DevOps PR gates so breaking changes are caught before review even begins. Time for the challenge. Here's the scenario. You're a data engineer at a mid-sized e-commerce company. Recent data incidents have eroded trust. Marketing is second-guessing the reports. Finance found discrepancies in the revenue numbers. And the data science team's model performance degraded because of upstream schema changes nobody told them about. Your job is to build a comprehensive data quality framework from scratch. 4 parts, 4 deliverables. Part 1 is a quality assessment. Audit the provided datasets across all 6 dimensions. This takes about 30 minutes. Part 2 is the Great Expectations implementation. Build expectation suites with checkpoints. This is the largest piece at 45 minutes. Part 3 is data contracts. Define contracts for at least 2 critical datasets. About 30 minutes. Part 4 is quality monitoring. Set up dashboards, alerts, and SLA tracking. Another 30 minutes. Your tech stack is Python, Great Expectations, and OpenMetadata. The target platform is Azure. You'll work with 4 datasets: orders, customers, products, and inventory, provided as CSV and PubKit files. Everything goes into a GitHub repository. The final deliverable should include all configuration, documentation, and a CI pipeline definition. Let's break down the first 2 parts in detail. Part 1, quality assessment. Start by profiling each dataset. Run column-level profiling to get null counts, distinct counts, min and max ranges, and type distributions. You can use pandas profiling or Great Expectations built-in profiler for the initial scan. Then score each dataset across all 6 dimensions on a 1 to 5 scale. Be honest, most of these datasets will score poorly, and that's intentional. Finally, identify the 3 most critical quality issues per dataset and document their business impact. The order ID column has 2% nulls, is a technical finding. 2% of orders cannot be tracked through the fulfillment pipeline, causing $50,000 in monthly revenue leakage is a business impact. That's the level of thinking we're looking for. Your deliverable is a quality assessment markdown file with the scoring matrix and prioritized issue list. Part 2, Great Expectations implementation. Initialize a Great Expectations project and configure the data sources. Build expectation suites for at least the orders and customers datasets, covering all 6 quality dimensions. Aim for at least 15 expectations per suite. The slide shows the minimum expectation types, but go beyond these. Create a checkpoint that runs all suites and generates data docs on pass or fail. Start with the auto profiler, then refine the generated expectations based on what you found in part 1. The profiler gives you a solid baseline. Your domain knowledge makes it production ready. Parts 3 and 4 complete your quality framework. Part 3, data contracts. Write YAML contracts for the orders and customers datasets. Each contract must include the schema definition with field types and constraints, quality SLAs for freshness and completeness, and ownership information. Define your versioning rules. What constitutes a major, minor, and patch change for your contracts. Then build a Python validation script that reads a contract YAML file and validates incoming data against it. The script should report violations clearly. Store these contracts alongside your pipeline code and add a validation step to your CI configuration. Part 4, quality monitoring. Set up OpenMetadata profiler, workflows for each dataset. Configure scheduled quality tests that run on a cadence. Build a monitoring view. This can be an OpenMetadata dashboard or a simple script that outputs quality scores per dimension over time. Configure alerting rules for SLA breaches. Freshness greater than 30 minutes, completeness below 99%, and any duplicates should all trigger alerts. Finally, write an incident runbook documenting trial steps for each alert type. Who do you notify? How do you remediate? When do you escalate? For Azure integration, use Azure Monitor and Logic Apps for alerting. Forward quality metrics to application insights for unified observability alongside your application metrics. Let's talk about where quality checks fit in your deployment pipeline. This is what ties everything together. The pipeline has 5 stages. First, the PR gate. When a developer opens a pull request, contract validation runs automatically. Schema diffs are checked against existing contracts. If a breaking change is detected, the PR is blocked before anyone even reviews the code. Second, the build stage, unit tests run plus DBT tests if you're using DBT for transformations. Third, the quality gate. This is the critical addition. Create expectations checkpoints run against a sample or staging dataset. If any critical expectation fails, the build fails. This prevents bad data logic from reaching production. Fourth, deploy to staging and run smoke tests. Fifth, continuous monitoring. OpenMetadata profilers run on a schedule and SLA alerting watches for degradation. The Azure DevOps pipeline YAML on the left shows exactly how to wire this up. Install great expectations, run your checkpoint, validate your contracts, and publish results as JUnit test results, so they show up in the Azure DevOps test tab. 5 best practices for making this work. Fail fast, fix fast, run checks early, separate warnings from blockers, critical checks block, advisory checks warn. Test contracts and PRs, version your quality config in the same repo, and track quality trends over time using Azure Monitor. Let's review what you need to submit and how it will be evaluated. 4 deliverables, each weighted. The quality assessment report is worth 20%. This is your foundation. The Great Expectations suite is worth 30%. This is the largest piece because automated validation is the highest value outcome. Data contracts are worth 25%. The contracts plus the validation script and CI integration. The quality monitoring dashboard is worth 25%. OpenMetadata configuration, alerting rules, and the incident runbook. The rubric has 4 levels. To exceed expectations, you need all 4 deliverables complete, a working CI pipeline with quality gates, and anomaly detection implemented. To meet expectations, you need 3 to 4 deliverables complete, Great Expectation suites with at least 15 expectations each, and contracts for at least 2 datasets. Developing means 2 to 3 deliverables with basic expectations and contracts without validation. Below means fewer than 2 deliverables or no automated validation. Aim for meets as your baseline and push for exceeds if time allows. The CI pipeline integration is what separates a good submission from a great one. Let's wrap up. Today you learned to measure data quality across 6 dimensions, implement automated validation with great expectations, define data contracts that formalize producer-consumer agreements, and set up monitoring to catch issues before they reach your consumers. The key takeaway is this: data quality is not a one-time project. It's a continuous practice that must be embedded in your pipelines, your CI/CD workflows, and your team culture. The tools are available. The patterns are well established. The challenge is making it a habit. Next month, we'll dive into streaming and real-time processing, event-driven architectures, Apache Kafka, Azure Event Hubs, and stream processing patterns. The quality practices you learned today apply directly to streaming data, so everything you built this month carries forward. Thank you for your focus today.